The monkey and hunter question. And so our hunter is here, and he is launching his Nerf gun at some V0 at some angle. They're a horizontal distance apart. When the hunter fires the Nerf gun, the monkey drops off the limb, and the limb is H high here. And the question is, what angle do you use in order for the Nerf gun to hit the monkey? And so the monkey's going to be released. The bullet's going to go. And so it really boils down to this. You have to be able to write a position equation for both the bullet and the monkey, which we can do. Because for the bullet to hit the monkey, their y values must be the same when their x values are equal. Meaning, when the bullet has traveled a horizontal distance of d, the bullet and the monkey have to be at the same height. That's like the definition of what it means to collide, right? To be at the same location at the same time. So let's focus on the bullet first. So here we have the bullet, and the bullet is just a projectile. So its horizontal position x is equal to v0 cosine theta t. Its vertical position is v0 sine theta t minus 1/2 gt squared, right? A no initial position, height or horizontal. So hold off on that then. And then over here we have the monkey. The monkey is at a horizontal position of d, right? Our coordinate system is assuming that the bullet is at the origin. And then the monkey's height, original height, y0 is capital H, and then minus 1/2 gt squared. Okay, so what we're going to do is we're going to do exactly what this says. For the bullet to hit the monkey, their y values must be the same when their x values are equal. Okay, so let's scroll down, and now let's look at this work. This is x bullet equals x monkey. The bullet is v0 cosine theta t equals to d, and I solved for t. This is the time it will take for the bullet to horizontally reach the monkey. So at that time, I want their heights to be equal. This is me setting their heights equal. The bullet, v0 sine theta t minus 1/2 gt squared, that's the bullet height at any moment, and then the monkey's height is h minus 1/2 gt squared. The first thing you should realize is that algebraically, I can cancel these two values and get this. Then I'm going to take this time, and I'm going to substitute it in for t, because I know at that moment, that's when the bullet's gone a distance d, and I want the heights to be the same. So take that time, put it in here for t, and get this. Cross out the v0s. Sine theta over cosine theta is tangent theta. Divide by d, take inverse tangent, and then you get this for your answer. The angle you want to use is h over d. And the real kicker in all of this is that that angle, inverse tangent of h over d, means you actually, should aim right at the monkey. Hopefully that makes sense. Look back at it again. Both the monkey and the bullet are under the same influence of gravity. I understand they're both going to fall, but they're going to fall at the same rate. And so, boom. If you aim right at the monkey at the start, you actually will always hit the monkey. Now I realize if you have a really fast gun, the monkey won't fall very much because the bullet will get there really quick. Well, then the bullet won't fall very much. If you have a slow Nerf gun, the monkey's going to fall a decent amount, but the bullet will too. So it doesn't actually matter the speed at which you fire the bullet. As long as the bullet has enough velocity to actually cover the distance, the bullet will always hit the monkey as long as you aim directly at the monkey. The biggest part of this is that number one, you can write position equations for both the monkey and the bullet. And the second part is you realize that for a collision to happen, that means they have to have the same x values and the same y values. So that's all I did here was I set them equal to each other, and then I did a little algebra. Okay? Hopefully this helps, kind of talk through the monkey and hunter question.